Hi and welcome to Meetings in Math. You are here for 7.1b, finding square roots, some practice problems. Our essential question is, how do you find the square root of a number? Today you'll need your Jaguar Jots, a pen or a pencil. You may find a highlighter helpful. You need to bring your bright ideas, your best effort, and always bring your problem-solving skills. This time you need to leave your calculator behind, but you might want to bring with you a multiplication table if your multiplication skills are not that strong. So we're going to start in with example number 2. And we need to remember what the word simplify means. Simplify in this case means that there are no more perfect squares left under the square root symbol. So what we're doing is we're extracting all those square roots out of the square root symbol. And so if you think back to our mystical forest, it means that they've gone through the tree and they've taken out all of the square roots. And if we don't have a perfect twin, if we don't have any twins there, sorry, you're stuck in our mystical forest and you don't get out. So let's look at these right now. On A1, we read this as the opposite of the square root of 49. And so the opposite just means the negative sign. And then we take the square root of 49, which is 7. And so our answer is -7. It's that straightforward. We're just taking our words together, we're mashing them up, and we're doing the problem. So now let's look at A1, the second one. That should say A2. This is saying, give me both the positive and the negative square roots of 49. And so we have to make sure that we write down that both the positive and the negative. So we say plus and minus, and then the square root of 49, which we already know is 7. And so now we're going to write that down as our answer. And so now let's look at the last one. The last one is the square root of -81. Can you think of a number that is the same number that multiplied to 81? Yes, 9 times 9, or -9 times -9. But now it's saying I need the same number to multiply to -81. Well, that's not possible because you can't multiply two positives and get a negative, and I can't multiply two negatives to get a negative. You have to remember that perfect squares are always going to be positive. You might want to even jot that down. Let me say that one more time for you. Perfect squares are always going to be positive. So this answer is not possible. So now let's look at example number 2. Example number 2 has taken our square roots and kind of messed them up a little bit this time again by putting them into a fractional form. But that's really not that big of a deal because what this is saying is give me both of the roots of the square root of 9/64. Well, some different things can happen. If I could reduce 9/64, I would. This case, not that big of a deal. What we're really going to do is we're going to break the square root into the numerator and the denominator. So instead, I'm going to take the two roots of the square root of 9 and the square root of 64. And I know the square root of 9 is 3, and I know the square root of 64 is 8, so my answer is really just positive and negative 3/8. How did I know that the square root of 9 and the square was 3 and the square root of 64 was 8? It's because I have them memorized. Or I'm looking at my multiplication table. So now let's look at another one. Let's find the square root of 484. Now this one I don't have memorized. So what I'm going to do is I'm going to go to making a factor tree. And I just start with some things I know. So I start with 484. And I say, okay, what are some things that I know divide into 484? Well, I know 484 is even. It's not the most efficient way to get there, but I know that it's even. So I divide 484 by 2, and I get 242. Now again, what do I know 242 is divisible by? Maybe not the most efficient way, but I know it's divisible by 2 and I get 121. Now, you will notice I am doing something that a lot of other math teachers don't do. I am pulling my 2, which is already factored down to this prime factor, down to this level. I do that so that when I'm done, I just look at my very last level and I don't have to come back up and find my final prime numbers. Remember, in a factor tree, you're doing everything down to prime numbers. So I'm taking this right here down to this prime number. So now I'm looking at my 121. Well, what do I know 121 is divisible by? Aha, this one I know. I know that this is 11 times 11. So I'm going to do that. And then I'm going to bring these down as well. And again, I'm bringing everything down to the same level so I don't have to go back up to find all my primes. And so now this right here, I can rewrite 484 as 2 times 2 times 11 times 11. And if I go back to my idea of looking for twins, I have one set of twins that is 2 times 2, and another set of twins that is 11 times 11. And now I'm going to go through the passage, and one twin disappears, never to be heard of again. And so I end up with 2 and 11. Since I have done the square root, since I've gone through the passage, it goes away. I've done that operation. So now I have 2 times 11, which is 22. If I want to check my work, go 22 times 22. Go ahead and pause it if you don't believe me. And I'm going to get 484. So now let's look at another one. Let's take the square root of 1.69, or 1 and 69 hundredths. So now, what does that remind me of? Well, it reminds me of 169, which would be 13 squared. It's just my decimal place has been moved over. Well, in the same way that when I have 2 zeros, I just know that the 2 zeros was that doubled 0. I know that 2 decimal places, right? If I multiplied 1.3 times 1.3, would move it over 2 decimal places. So it's knowing and understanding what decimals do. So now I know that this is 1.3 times 1.3. We're going to go through the magical tree in the mystical forest. One of our twins is going to disappear. I'm coming out the other side of the tree, so the square root goes away, and I'm left with 1.3. Go ahead, pause it, multiply it back out. Yes, 1.3 is equal to 1.69, which means this does work. So what about 7,200? This one's getting ugly. It has the 2 zeros, so I lop those off and I look at 72. 72 is not a perfect square that I know of, which means I'm back to doing a factor tree. I'm at least going to do 172 and try to make this as small as I can. And I know that 100 is 10 times 10. 72 though, well, that's 9 times 8. I'm getting there. So 9 I know is 3 times 3. So I do have some twins there. And I know that 8 is 4 times 2. And it's okay. And 10 I know is 2 times 5 and 2 times 5. So I'm going to pull those 2's down and those 5's down. And 4 is 2 times 2, and then I'll pull the 2's and the 3's down. Okay. So right here I have 1, 2, 3, 4, 5 2's, 2 3's, and 2 5's. So let's go ahead and just write all of those down. I have 1, 2, 3, 4, 5 2's, 2 5's, and 2 3's. And remember, we're looking for twins. So I have a set of twins, and I have a set of twins. But that last 2, no twin for you. A set of twins and a set of twins. One twin gets out, the other one vanishes. One twin gets out, the other one vanishes. This twin can't even go through the tree. This one's stuck in the forest, which means it's stuck underneath that square root. One twin gets out, the other one vanishes. One twin gets out, the other one vanishes. This is the twin that can't get out of the forest, can't get out of the square root. So now we're going to do 2 times 2 times 5 times 3. When I do those quickly, I get 60, and then that square root of 2. That square root of 2 is this one right here. It didn't have a twin. So sometimes we're going to end up with things that can't come out of the square root. Why? Because it didn't have the twin. It's not a perfect square. This is really the square root of 4. The square root of 4 is 2. The square root of 4 is 2. The square root of 25 is 5. The square root of 9 is 3. The square root of 2 is just the square root of 2. So it's going to stay right there. 2 times 3 is 6. 2 times 5 is 10. 6 times 10 is 60. So be careful. There are times that you cannot take something out of the square root. So here is what I would like you to do. Now that we've done all these problems, I would like you to create a square root problem whose answer is 5 root 3. So in other words, think about what you would have to do to this 5 to put it back into the square root. What about this 3? Is there anything you need to do to this 3 to keep it here? See what you can do with that. Thank you so much for joining us. This is a great lesson. It's a great introduction to all the type of problems that we're going to need in order to do problems further on. Remember to be kind because we all could use some extra kindness in our lives. Bye for now.